Today we're going to do a little test to see how well you're understanding the concept of gravity, air resistance, and the effect of weight and surface area. So, what we already know about gravity from the other class. Gravity is a force that pulls everything down. Everything on Earth is affected by gravity. And without gravity, we would just float away into space. So to start, I want you to look at this image. We have two parachuters. One has a larger and one has a smaller parachute. Now, if they were to be jumping out of a plane, I want you to make a prediction. Would the man with the larger parachute or the man with the smaller parachute reach the ground first? So let's say our response is, oh, well, I think the man with the larger parachute is going to fall first. Now, if I ask you why you think he would reach the ground before the other man, you would probably say, well, the bigger parachute weighs more. And yeah, you're probably right, but I want you to think more about, we know gravity's pulling down, and if something was to, let's say, pull up, would this be harder to pull up or the smaller parachute? Together as a class, we could predict that the larger parachute will have more resistance falling down from the air resistance that pushes up. This is because the larger parachute, of course, has more surface area than the smaller parachute with less surface area. So now I want you guys to put this to the test yourself. Let's do an experiment. Collect all of these objects that we will need for the experiment. One piece of paper, any paper you choose, colored, white, whatever you want to use. One pencil, one of our rocks from our class collection, and your math textbook. On a lined piece of paper, I want you to make a table or a chart that looks like the example I have for you on the board. And just make sure you include the same labels. You need your object name, which will be these four objects, the weight of the object, which you will do as well. You want to make a hypothesis, which, as we learned, is our educated guess on what will happen. And then we will be measuring the time it takes for each of these objects to fall from a measured distance. I want to check in and make sure that everyone has a chart that looks like this one. You have your labels up top with object name, weight, your hypothesis of which will fall first to last, 1 through 4, and then we're going to measure the time it takes to fall from a measured distance. So here are my 4 objects. By now you should have your weights measured. Next, I want you to make your hypothesis of what's going to fall the fastest, number 1, to the slowest, number 4. Now remember, your hypothesis is a prediction based on what we know about gravity being a force that pulls down, air resistance being a force that pushes up on an object, and how the surface area and the weight can affect a falling object. So fast forward to after they would perform their experiment, they would see if their hypothesis they made about what object would fall first to last based on the weight, surface area, and their previous knowledge of gravity and air resistance was correct or wrong. I'd ask questions like, well, if we had 2 apples weighing different weights and we dropped them from another measured distance to the ground, would they fall the same or different timing? You could also follow up this experiment asking, if I were to drop a ball with buoyancy, what would happen? Hopefully their response would be something along the lines of, well, the ball would drop to the ground and bounce a few times. Then you would also ask, well, what if I threw the ball in front of me instead of a direct fall down? Would it behave any differently? And this would also be followed by the response, well, the ball would drop to the ground at another distance and still bounce a few times. This is an example of constructivism because they take their previous knowledge of gravity and air resistance, added with weight,